All right, hello everybody. We're going to talk about sorting images by color. The main focus is going to be some pretty cool scoring techniques in Elasticsearch. I'm Hundley. I'm the lead developer at qbox.io. We're an official partner of Elasticsearch, and we provide cloud-hosted Elasticsearch. I apologize in advance if you're prone to epileptic seizures, but this is a gift of the end result. It's about 130,000 images, and we're getting about 200 milliseconds per read. So there were three things I needed to figure out to make this happen. Modeling color data in JSON, getting the actual colors out of the image, and then scoring images with respect to the color being searched. And there's quite a few ways to model color numerically. Hex and RGB are really common, but I chose HSL. There were a lot of advantages, but most importantly, Q, the first number, gives you a simple integer that represents somewhere along the rainbow, somewhere along the color wheel, which is perfect for grouping colors. Here's a little diagram of all the stuff that happens before we're actually searching the indexing process. So images are fetched from Flickr, take the URL down of the image, iterate for each pixel, count the unique colors, store that back in the document into Elasticsearch. After all that happens, here's what we wind up. We have URL, views, stars, and then this nested array of 20 of the most frequent colors. You could definitely store as many colors as you want. More colors, more accuracy, but you're going to need better hardware, and it may go quite a bit slower. So after I had all the images in, I was able to cook up a scoring formula. I don't have really strong math chops. I just knew I needed to sort primarily by color similarity and to some relative degree image popularity. So the highest quality images would be at the top. First attempt, really slow. It's about 6 seconds per query. The left side is what I'm calling the color similarity score. It's really just the Pythagorean theorem, finding the Euclidean distance from the input HSL to each HSL in the document. Sum those, negate it, add it to a base 10 logarithm of views times stars, give us a rough image popularity score. So this is really slow, really ugly looking. The results weren't that good. I needed to control H, S, and L separately. They needed to have different space. So adding factors to the script only made it slower and even grosser looking. So I found function score query. It was rolled out in 1994, so it's a relatively new feature. I had no idea what the K functions were. Figured it out, they're pretty simple. The gist, though, is each of H, S, and L receive higher scores for how close they are to the input HSL, the color being searched for. Reduced apparent code complexity, really sped things up, and so the results were a lot better. Here's what actually happened to the color similarity formula as a result of that. I didn't have to write that, Elasticsearch did, so it made my life a lot easier. And I really like this, you can probably see. I thought it was important to really show what was happening during the scoring process, since there was a nested layer of scoring. So each color in the document is compared against the input color. Those scores are summed, added to this random image popularity score. And so, as you can probably see from the last slide, just adding image popularity blindly to the color similarity score caused some weird stuff to happen. It could cause really low color matches to rise to the top if an image was really popular. And so Rescore, another feature that was released in 090, instead of adding image popularity to the base color similarity score, we could score only by color, simplify things, and then reorder those top 200 results by popularity. So that didn't speed things up, but the quality of results were much better. So last but not least, the filter. I probably should have started with this. Really sped things up. accounts about 12% of that. So only images containing a color within that certain hue range will be scored. And that is it.